Greetings, welcome to this new video about Kirchhoff's laws KCL and KVL. Given the electric circuit with R1 is 2 ohms, R2 4 ohms, R3 4 ohms, and R4 is 8 ohms, and we have two voltage sources, V1 10 volt, V2 is 6 volt, and we have a current source IS is equal to 2 amps. The question now is to calculate the current through each resistor using Kirchhoff's laws. Let's go to solution. We start always with the step number 1 is to choose the direction of the currents. This is I1 is the current through R1, I2 the current through R2, I3 is the current through the resistor R3, and I4 is the current through the resistor R4. And we know here this current is in this branch is I1 minus I2. After we finish step 1, we go to step 2 is to identify the polarity of each resistor. We know that the current flow from the high potential to the low potential. That means this is positive and negative of R1, positive and negative of R2, positive and negative of R3, and positive and negative of R4. Now we go to step number 3 is to apply Kirchhoff's current law KCL. We can see here at node A that I1 is entering the node, I2, I3 and I4 leaving the node. Then we can write KCL at A, I1 is equal to I2 plus I3 plus I4. We go now to node B. We have I3 is entering the node, IS is entering the node B, and I1 minus I2 leaving the node. We can write KCL at B, I3 plus IS is equal to I1 minus I2. After we finish applying Kirchhoff's current law, we go now to apply Kirchhoff's voltage law KVL. Before we start applying KVL, we need to choose the different loop we are going to use here. This is loop number 1 and this is loop number 2. We can write KVL in loop 1, negative V1 plus minus R2 I2 minus R1 I1 is equal to 0. We obtain finally negative 10 minus 4 I2 minus 2 I1 is equal to 0. We go now to loop 2. We can write here R2 I2 minus V2 minus R3 I3 is equal to 0. Finally we obtain 4 I2 minus 6 minus 4 I3. After we finish applying Kirchhoff's laws KCL and KVL, we obtained 4 equations with 4 unknowns. Now we only need to solve those equations in order to find I1, I2, I3 and I4. Let's start first with equation 3. We have negative 10 minus 4 I2 minus 2 I1 is equal to 0. That means negative 5 minus 2 I2 minus 1 is 0. If we divide the whole equation by 2, we obtain negative 5 minus 2 I2 minus I1 is equal to 0. Finally, we can write I1 in terms of I2. I1 is equal to negative 5 minus 2 I2, and I will call this equation A. I will go now to equation 4. We have 4 I2 minus 6 minus 4 I3. If we divide the whole equation by 2, we have 2 I2 minus 3 minus 2 I3. Finally, we can write also I3 in terms of I2. That means I3 is equal to I2 minus 1.5, and I will call this equation B. Let's consider now equation 2, and by replacing A and B in 2, we obtain I2 minus 1.5 plus 2 is equal to negative 5 minus 2I2 minus I2. Finally, we have 4I2 is equal to negative 5.5. That means I2 is negative 5.5 over 4 is equal to negative 1.38 amps. After we calculate I2, we go back to A. We have I1 is negative 5 minus 2I2. We obtain finally I1 is negative 2.25 amps. We go back to B. We can easily find I3 is equal to I2 minus 1.5. That means I3 is negative 288 amps. We go back now to equation 1. We can rewrite equation 1. I4 is equal to I1 minus I2 minus I3. That means I4 equal to negative 2.25 plus 1.38 plus 2.88. We obtain finally I4 2 amps. After we finish calculation, we have done simulation using SPICE simulation in order to verify our calculation. Let's go take a look about SPICE simulation. Here is our circuit made by SPICE simulator. We can see here the first voltage source 10 volt. This is the second voltage source 6 volt, and we have here our current source 2 amps, and we have the 4 resistor R1, R2, R3 and R4. If we go now to analyze, we go to DC analyze. Let's use table of DC results. I will remove here the nodal voltage, other voltage. I will leave only the current. Let's now see the current through R1. That's negative 2.25. This is the current through R2. That's 138. This is the current through R3. That's negative 288. And this is the current through R4 is 2 amps. That's exactly the same value we have found by calculation. Thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will try to reply you as soon as possible. Take care and see you next time in another example about Kirchhoff's laws. Bye bye.